So, welcome to my dear student. So, today we are going to learn two more classifier that is called random forest classifier and another is called naive based classifier. It's basically Gaussian classifier. It's a stochastic process. So that is basically Bayes theorem. I think you studied in your mathematics or statistics part. That means who are the students of economics or like this they have studied. It's a, conditional probability. So I'm not going to detail about the mathematics behind it. Just we are going to learn the syntax very quickly. So we'll go to Anaconda and we'll open. So for that, actually, I'm going to use that. Already this file we have used. So these are the pathological details of 7 patients. So the first column is that is the blood pressure, then the blood glucose, then the pulse and the cardiac output in liter per minute, and then the nature of the uh, uh, clinical conditions. Means clinical identification. So uh, this 0 is indicating his feet, one is glycemic and two is hypertension. So this using this small table we are going to learn that. So here we will, so that is Jupyter notebook. So let us create a new file and the name we give random forest and naive bias base classifier. So first we'll import panda as pd, then we will read that file. So I am giving one variable named dt, which is pd.readexcel. Read excel. We are very much familiar with all these commands because several classes we have completed. So let us go to the properties, and this is the location, and the file name is mc.xlsx. So here, so that is mc.xlsx. Okay, and now we are running this. Let us see the data. Okay, so the same thing has come. So now we have to define the dependent and the independent variable. So independent variable let we define as x, denoted as x, and that is in dt. So that will be in your bp, then your blood glucose, then your pulse. Okay. Hmm. And then uh, the cardiac output. Okay, and your dependent variable will be the out, the variable called out. Okay, now we have to split the data for train and testing. So from sklearn dot model underscore selection import train underscore test underscore uh, split. Okay, so now this is what is this here? From what is this here? From scalar dot model underscore selection import. Why this is showing? So here train. So now this will be your X. So this is your X underscore train, comma X underscore test, comma Y underscore Y underscore train, comma Y underscore test is equal to train underscore test underscore split. That is my independent variable, then the dependent variable, then the test size is equal to I am using 30% for testing. Okay, so now we have to import that particular classifier, so that from uh, sklearn dot uh, ensemble import, so import random forest uh, classifier. Okay, so uh, the syntax error it will be sclassif so this will be, so here a random forest classifier, a random in So this will be, so this is the thing, and now we will define one class which is that will random forest classifier. Then we will see the shift tab. So what are the argument? So we'll use this. So these are the caps. This is the this one. So this is a Gini criterion. Already we learned it. Okay. So now this. Now we will using this. We'll fit. We'll train. Okay. So the dot fit. We'll use that dot fit. The the class classifier dot fit. Then x underscore train comma y underscore train. Okay. So let us run it. Yeah, it is trained. Then let us predict CLA dot predict. So this is x underscore test. Okay. So it is. Let us see what is x underscore test. Now you see the first one. We can tell it is this person is hypertension, and this is fit, and this is glycemic, but still because this data are very less, so that's why we can check the score also. Okay, this CLA dot score of that is x test, y test. You can check. See, only 66% because the data are very less. That's why. Okay. Now you can see the another syntax, that is naive base. Actually, a lot of things it is difficult to always remember. Google is there, so you need not to bother. So we'll import this. So okay, then we will define one model, which is this one. Okay, now we will feed that model dot feed. This is x underscore train comma y underscore train. Okay, it is trained. Now let us predict. So this is model dot predict. So that is x underscore test. Okay. You see, it is giving. Let us see the x text test. So this is hypertension. So it is again. You can see the score. You see, it is only 33%. So that's why it is coming error. So we need to increase the data set, then uh, it will come. So this is all about the classifications, and today only today by today night I will conclude the course. So that's why I thought two more classifier are very important while we will be working in practical field. So that's why I detailed, and this for syntax and all, you just, if you know the mathematics, frankly speaking, when I studied this kind of much more, this Python coding, all these things, it was not there. I only can manage with the situation because I have very clear concept in mathematics. I understand from the syntax itself, I will understand that what they are trying to do, and the things become much more clear to me. This machine learning, deep learning, and everything, it is depend on mathematics only. You must have the very clear conception on mathematics. Still, I am moving always with, in my desk there will be a book called Higher Engineering Mathematics by B.S. Grewal. I suggest you, all of you should keep that book always with you. If you want to become a good engineer, good data science expert, and without mathematics you cannot become. Okay, so you should know the mathematics. So I hope this syntax are clear to you. Thank you so much. Thanks for your patience.